Let's see the next example, which is exercise number 16. It says, the first, second and third terms of a geometric progression are equal to the first, fourth and 16th terms of an arithmetic progression respectively. The common value of the first terms is equal to 5. Calculate the fifth term of the arithmetic progression and also the sum of the first 5 terms of the geometric progression. So, as you can see, here we have the formulas that we will need to the arithmetic progression and to the geometric progression. Alright, so what we have here, we have two series, two progression. A is a geometric progression, which means that I get the next element of this progression if I multiply the previous ones, and I have a B, which is an arithmetic progression, which is that I get the next element if I add or subtract something from the previous one. Okay, and I usually denote it by EN and BN. This is the series, this is the sign for that. And what I know is that so A1 is equal to, so the first term of this geometric progression is equal to the first term of the arithmetic progression. So what I know that A1 is equal to B1, and I also know that the common value of the first terms is equal to 5. So I know that both of them is equal to 5. What I also know that the second term of the geometric progression, that is A2, is equal to the fourth term of the arithmetic progression, so that is B4. Now here's the general rule of how to create a progression. So let's apply this. So if I have A2, which is a geometric progression, then the second term can be calculated in a way that A2 is equal to A1 times Q to power n minus 1, which is 2 minus 1, which is 1. So and A1 is 5, so 5 times Q. This is A2. Okay? And now let's see how can I calculate B4. B4, because B is an arithmetic progression, I have to use this formula, which is A1 plus n minus 1 is 4 minus 1 times D is equal to 5 plus 3D. So I know the first one, that because they are equal, then it means that the 5 times Q is equal to 5 plus 3D. This is the first thing I know. Okay? Now I also know what is Q, by the way. The Q is the quotient of the series of this progression. It means that this is the number I multiply a number so that I can get the next one, and the D refers to the difference between the two terms in the arithmetic progression, in the B series. Okay, so now I also know another thing, that the third term of the geometric progression, which is A3, is equal to the 16th term of the arithmetic progression, which is B16. Now what I have to do is exactly the same like what I did before. I calculate the A3 and B16 using this general rule. Okay, so A3 is how many? A3 is equal to A1 times Q to the power minus 3 minus 1, which is 5 times q squared. Okay, because this is the third term, so n is now 3, and then n minus 1 is 2, and the first term is 5. We all know this. And then let's calculate b16 as well. b16 is equal to a1 plus n is now 16, so 16 minus 1 times d is actually 5 plus 15 times d. Okay, so this is another thing I know, that this is equal because a3 is equal to b16. So what do I know now? I know that 5q squared is equal to 5 plus 15d. Okay, so now if I check, I know this one and this one. This is the two how do you say, connections that I know and I want to use. And this is actually a set of equations. I have two unknowns, q and d, but I have two how do you say, equations as well. Okay, so what I can do now is, for example, I can calculate for let's do like this. I have to calculate the value of one unknown, for example d, from this equation, and I have to plug this into the second one. Okay, so from the first one I know that 5q is equal to 5 plus 3 plus 3d. It means that 5q minus 5 is equal to 3d, and 1/3, let me go a bit deeper, 1/3 times 5q minus 5 is equal to d. Okay, now I know how much is d. I expressed it with the help of q, so now what I do, I plug this in here to the second one. Okay, so I know from the second that 5q squared is equal to 5 plus 15d, which is 5 plus 15 times 1/3. Now I use the d, what I got from the first one, 1/3 times 5q minus 5. Okay, which is equal to 5 plus 15 over 3 is 5 times 5q minus 5, which is 5 plus 25q minus 25, which is actually 25q minus 20. And now I know that this is the one side and this is the other side, so I just use the here, I write it here, so I collect everything to the left side, so 5q squared, I can okay, minus 25q plus 20 is equal to 0, and I can distribute by 5, and I get q squared minus 5q plus 4 is equal to 0. And this is a basic equation that I can solve, and then I will get the equation, I will get the value of q, but I will do this in the next video.